welcome to the latest episode of Pioneers, Siemens Startup Podcast Series, where we speak with entrepreneurs to gain insight into how they turn their innovative dreams into successful companies. I'm your host, Kevin Blevins. The world is in the midst of the commercialization of space. Just consider this. There are 4 countries that have landed on the moon. And in case you haven't been paying attention to this, those 4 countries are the United States, the Soviet Union, China, and most recently, India. Some argue that this all began with SpaceX's inaugural rocket launch. The Federal Aviation Administration, however, would argue it goes back to 1963. And regardless of your opinion, one thing I think we can all agree on, it is an exciting time to be in the aerospace, or more specifically put, the space industry. According to Google, there are over 100 launch companies, with some already in regular operation. And when I say 100 launch companies, I'm talking about 100 commercial launch companies, with some of them already in regular operation. Companies like SpaceX, Rocket Labs, and ULA. But what happens when the payloads these rockets are carrying gets to space? Satellites are a great example. How do satellites, which are payloads, move from their drop-off points to the specific orbit assigned by the International Telecommunications Union? Today's guest will help us better understand what happens and how they plan to help satellite builders access any orbit, as they say on their website. Today I'm speaking with Dan Olson, Vice President of Engineering at Impulse Space, a US-based startup company developing infrastructure to help further the commercialization of space. This is important to give companies options as they deliver their payloads to the right orbits in space. Hello, Dan, and thank you for taking the time to speak with us today.
Morning, Kevin. It's great to be here. Thank you for having me.
Well, we very much appreciate you taking the time. I know as an individual working at a startup, you're a busy guy. So, Dan, I'd like to start by asking you to tell us a little bit about your background.
So, my background is I studied mechanical engineering at Penn State University. After graduating, I had a decision to make. I had a job opportunity with Sikorsky to go and design helicopters in Connecticut. And I had another opportunity to pursue a career in motorsports, designing race cars down in North Carolina. And I chose the latter, thinking that I would do it for a couple of years. Ended up in the motorsports industry for the better part of a decade. During that time, I was able to do a whole bunch of design work, mechanical testing, CFD and aerodynamic testing. Eventually moved on to leading our vehicle simulation effort, and then ultimately started an aerospace division for the race team, just to help the race team diversify and branch out into new arenas. The race team was particularly suited for that too, having engineering and testing and manufacturing capability in-house. That ultimately led to me transitioning over to Impulse Space here in 2021.
What made you go from designing race cars to some degree designing and developing space cars?
They're remarkably similar. It doesn't seem that way at first, but really the methods we use to go about designing each, gathering the requirements, using kind of cutting edge materials and analysis methods, design methods, and having to solve some kind of innovative challenges for each, lead the process to be very similar for both. The methods are similar again, so there's kind of a nice synergy between the two, I guess. And you see a good number of people from the automotive and motorsports industry in aerospace.
That's interesting. I didn't realize that. So what was it about Impulse that drew you in?
Impulse was really attractive to me because it was an opportunity to build something from the ground up. Being at a startup, you don't have the typical resources and systems in place that you do with an established company. And that's something that I find really fun and exciting, is hiring the right people and putting the right tools in place and building up our manufacturing capability and building up our engineering capability. It's kind of that creative element. You get to put your own twist on it and ultimately try and do it better than you did the last time.
And that's a little different than race cars when you consider that NASCAR controls a certain level of the vehicle, right?
It's true. The thing that is kind of synonymous in the aerospace industry, though, is we do have regulating bodies. They're similar to NASCAR in racing. You have your launch provider that has certain requirements for the payload going up to orbit. They have all sorts of rules about the size you can be, the strength that your spacecraft needs to be, the environments that it can survive, things about how it operates, when it can operate. You also have the FCC and the FAA that also have regulations pertaining to operating a spacecraft. So it was kind of fun learning about, all the different nuanced regulations and rules, and then again, trying to design the best product around those regulations and rules.
Yeah, space is a harsh environment. I don't think everybody realizes that. It's vast and it scares a lot of people, but the temperature swings are tremendous. And then the whole idea of radiation and what radiation does to a product up in space. But did you find it hard moving from the race cars to space?
There's certainly a steep learning curve. The environments are probably the most significant difference between operating on the ground in our atmosphere here and operating in space. Luckily, we have a great team of folks here that have a variety of different backgrounds, some with extensive in-space experience, some with extensive launch vehicle experience, and a really good culture where we're able to lean on each other to learn different things. So I've definitely leaned on a bunch of my colleagues to learn as much or find the right resources to where I can go and read up or learn more on the environments that we were going to experience in space. At the same time, some of the methods that we use are similar, where for a thermal analysis, we built up a thermal model similar to what we would in the automotive industry. Get all of our inputs, we do all of our testing to validate that model, and do our best to make the best approximations to get the best model outputs.
Were there important lessons you took from working at Joe Gibbs Racing that have shaped your approach to what you're doing today?
Yeah, I think there are some things that we did at the race team that we're applying here. And that was one of the things that drew me to Impulse was our founder, Tom Mueller's attitude toward doing things such as vertically integrating. The concept of we're going to design and build and test and integrate everything in-house is something that we did at the race teams. We had complete capability there. And we're building out that capability here at Impulse. And what that allows you to do is it allows you to innovate extremely quickly. You can go from concept to prototype to having it tested and getting it through a qualification campaign and onto the spacecraft in a very short period of time at a reasonable cost. Whereas if you're relying on outside vendors and suppliers, you're beholden to their schedule slips, pricing, all of the NRE that they're going to incur. So we feel like this is a much better way to approach building spacecraft and being able to iterate on those spacecraft to ultimately produce the best line of products.
That's a great lead into talking more about Impulse Space and what Impulse Space does. So can you tell us about Impulse Space and the innovative things that the company's doing?
Yeah, Impulse Space is an in-space transportation company, and we like to think of ourselves as being the premier for in-space transportation. We're developing orbital transfer vehicles, also known as space tugs, to be able to go up on a launch vehicle, as you mentioned, like a Falcon 9 or a Vulcan Centaur or New Glenn or Rocket Lab, Relativity, any of these new launch vehicles. We're kind of launch vehicle agnostic, and go and deliver payloads to different orbits or reposition payloads from one orbit to another orbit. We have kind of a roadmap, a technological roadmap that we're working through toward offering additional services to, such as in-space servicing and in-space refueling too.
How does Impulse Space and what you're doing today impact the future of space? The reason I ask this question is because there are ways of getting to different orbits today, right? And what is it about Impulse Space products that's going to change that?
What we're seeing right now in a space environment is a big shift in the cost of access to space. With all these new launch providers and the reusability of the launch vehicles, we're seeing the cost of delivering a kilogram to low Earth orbit rapidly declining. And we expect with Starship, it could be another order of magnitude lower than it is today. And with that, we're going to see a lot of stuff going to space in general. So Impulse is poised to be able to deliver all of these things. So we're trying to do what launch vehicles are doing to offer access to space in space. So we're looking at basically reducing the cost of repositioning and offering refueling and doing all of this servicing activities through our vertical integration. So if a major aerospace company were to tackle the problem that we're trying to tackle, it would cost a lot more. It would be delivered in a lot longer timeline. We feel like we're very agile and well suited to produce an economical solution for all of these in-space payloads.
Yeah, that's one of the beautiful things about a startup company, right, is the agility, being able to move fast and change gears and pivot from one position to another, right? That's a great thing. I'm always interested in where the name of the company comes from. So if you know, the founder, as you mentioned, Tom Mueller, is there a story behind the company name?
Impulse obviously comes from specific impulse, which is kind of the metric which we use for essentially propulsion system performance. From specific impulse, we just shorten it up to impulse, and that's kind of what we're known for. So being that like in-space transportation, experts in propulsion, that's where the impulse name comes from.
And do you develop your own propulsion systems?
Absolutely. We have a line of thrusters here, ranging from less than a pound of thrust all the way up to 20,000 pounds of thrust that we're developing right now. So we have a launch coming up shortly that we will be featuring our 5-pound thrusters on, and looking forward to getting those things in space and operating them.
That's interesting. And your launch, how soon is that? Or is it planned today? Is there a date set for it?
It is. It's planned for November, the beginning of November, be on a Falcon 9 rocket. The spacecraft is here in our factory right now. We're going to be shipping out in about 3 weeks.
There's a name given to that vehicle, is there not?
There is. That first vehicle is called Mira.
What's the significance to Mira, other than it's your first vehicle going into space?
Yeah, so Mira is one of the stars in the constellation Orion, and Orion is one of everyone's favorite constellations, and we thought this would be a kind of a nice tribute to that.
Well, I live in Arizona, and I'll tell you that Orion stands out like a thumb down here. I don't know if it's like that everywhere, and I never really realized it until I learned more about it. So that's great. When it comes to the payload, and just so people get an idea of the size, when I think about a Falcon 9 payload, I think it's like 23,000 kilograms or around 23,000 kilograms as far as payload space. How much of that space will Mira take up?
Mira is a fairly small vehicle. So Mira is about 300 kilograms with the payloads integrated on it. We'll be riding with a number of other payloads in November. There will be about 60 or 70 other payloads on this launch. So once we achieve orbit, SpaceX will deploy all of those payloads one at a time over the course of a couple hours. We'll all be waiting around the consoles nervously, awaiting our separation and confirmation that we did have a successful separation. And then we'll begin going about our mission operations at that point.
That's awesome. And I'm glad you said the number of other payloads that are going to be on this. When you think about 60 or 70 other payloads, right? And I don't think people realize it because they hear about SpaceX launches and they hear about Starlink and the number of satellites that go up with Starlink. And part of it is you can see the Starlink satellites, they're lit up in the sky and how they separate and things of that sort, especially here in Arizona. But I don't think people realize that there are 60 or 70 payloads on one of those Falcon 9s going up. That's amazing.
It's part of their rideshare program where they launch roughly 4 times a year these rideshare missions. And again, it's a great way to offer affordable access to space. The alternative to that, or historically, you'd buy a dedicated launch where there may be some opportunity for mission management to manifest multiple payloads on there, but predominantly there was a single payload that launch featured, typically a large, expensive communication satellite that was considered the primary, and you might have some secondaries on it. So SpaceX bringing about these rideshare launches really opens up a lot of opportunity for companies like ours to get going and to get into space and get experience on orbit. at a reasonable cost. We're going up on Transporter 9, so it's the 9th mission here. We're also booked on a couple of future rideshare missions too. They're booking about almost 2 years out in advance right now.
That's great. And who knows, you might even be on the same rocket that a Tesla is on, right? When you tug a payload, once you get into space and your mission begins, now you're getting Mira out and getting it ready to do its work, right? I'm assuming you have to connect to other payloads that are coming into space. Do you have some sort of standard interface to be able to connect to those other payloads?
Yeah, so that operation is considered in the industry, what we call RPOD, or Rendezvous Proximity Operations and Docking. It's a very new capability that the industry is still trying to standardize and develop, and there's almost a race to figure out who's going to come up with the best method for being able to dock and attach to different satellites and different payloads. So our early missions, we'll be doing delivery and deployment, and we're going to continue to develop a reliable docking mechanism and methodology to where we can identify the other payloads that we want to dock with, and then appropriately and gracefully attach and dock to them. Docking operations in space are inherently difficult because you really only have the momentum of the other vehicle to be able to react against. So things that are light and small tend to be very difficult and problematic to dock with. Larger and heavier things, such as like the ISS, International Space Station, tends to be a little bit easier.
A little more forgiving, a little bigger, right? Moving a little slower.
Yes.
When Mira tugs a payload to orbit, how do you ensure that you are not going to be hitting space trash?
Oh, that's a great question. So there are a couple of different registries that monitor all the objects in space. And I'll say the objects larger than a certain threshold, basically larger than about the size of your fist. All of those are controlled, and you have to file with the Space Force for a certain orbital slot, and you have to communicate if you intend to change your altitude or your inclination or a RAN change to ensure that you don't hit other spacecraft. There is a chance there's a lot of small debris up in space that is also moving around at a high rate of speed that is not tracked. But there's statistical methods that we can use to give ourselves probability of hitting that space debris or the space debris hitting us. And there's always some risk in that. And you build in some protection in your spacecraft to, I guess, ensure that if you are hit by some of these smaller pieces of debris, that your mission won't be compromised in there. So we build in shields, they're called Whipple shields actually, that protect us from micrometeorite and orbital debris damage.
That's interesting. Now that I did not know. So does Impulse have additional products beyond Mira, your propulsion systems and shields that you're working on?
We are continuing to develop new products all the time. You can think about Mira as a product that is evolving continuously. So the Mira that we're launching in November, we'll continue to make improvements and upgrades on and continue to offer that as essentially our smaller orbital maneuvering and servicing vehicle. We're also working currently on a larger, higher energy stage that I mentioned, the 20,000 pound thrust engine earlier. That'll be going on our larger vehicle, Helios, that will be able to maneuver several tons of payload instead of the several hundred kilograms of payload that Mira can maneuver.
So I read in the news that Impulse Space is working with Relativity to perform the first ever commercial landing on Mars. Can you elaborate on this?
Yeah, absolutely. So the Mars mission is one of our coolest missions. In fact, if anyone can see the video here, I have our prototype of the Mars lander behind me. Basically, we've partnered up with Relativity for the first Terran R mission, which is their new large launch vehicle that is slated to launch in 2026 to do the first commercial mission to Mars. So Impulse is taking on the work of designing the cruise stage and the aeroshell and the lander for that. So we are looking to do a soft touchdown on Mars as a demonstration that it's possible for commercial companies and organizations other than large government entities such as NASA to be able to deliver payloads to surfaces of other planets. So it's an ambitious mission. It's one that we're really excited about. And we are partnering with NASA to learn as much as we can about their previous missions. They're very good at doing this now. They've been great to work with in terms of helping enable the commercials to do for lower cost what they've been doing for decades now.
Yeah, when you talk about learning from NASA, it was pretty amazing to see the drone and what they had to do to that drone in order for it to be able to fly on Mars, right? That was pretty neat.
Very little atmosphere there, yes.
Yeah, that was a neat thing to watch and to hear all about. You talked about your mission. So you have the Mars mission, you have a mission that you have coming up. Do you have a certain number of missions that are already scheduled?
Yeah, right now the mission coming up in November, our first launch, is our primary focus. We have the Mars mission in 2026, and we also have another mission coming up in June next year on Transporter 11 with SpaceX, where we'll be taking additional customer payloads at that time. And there are other things in the works, but I can't talk about them at this point.
Ah, there you go. Okay. But it's pretty amazing. I think if for those who might be listening, it's pretty amazing for a startup company to be in this position where you already have 3 different missions that you can talk about and others that you might not be able to talk about, right? That's a pretty amazing thing. What about future goals for Impulse Space and the products that you're building? Are there key goals that you'd like to be able to talk about or that you might be able to talk about?
Our goals as an organization are to be the premier in-space transportation company. So we want to be able to do it economically, and we want to be able to do it reliably. We want to increase our space economy, just like many of these other space startups do. So again, we're doing that through our vertical integration. And I think over the next decade or so, we'll really be focused on trying to adapt our product offerings and our service offerings to what the in-space economy needs. And it's hard to predict that today, but I think we're well poised because we are small and agile and we have an ability to react quickly. And that will allow us to be, again, that kind of premier in-space servicing company.
Yeah, that's exciting. So you've chosen to work with Siemens. What is it about Siemens or Siemens products that made you choose to move in that direction?
Siemens offers a fantastic product line. NX and Teamcenter is a really powerful combination. It's something that's widely used in the aerospace industry. We have a lot of employees that have prior experience with the Siemens products, so very easy for them to come in and on the first day be productive with the software and the technology. We also have a bunch of folks here who have been using the products even since back in the Unigraphics days. So again, a lot of knowledge about the product, and it's a product that works, and it's something that we're really excited about. And the pace at which Siemens continues to develop the software is fantastic. New features are coming out all the time.
You spoke about the company being vertically integrated. Can you speak to the value or the benefits that you've seen from the Siemens product line in helping that vertical integration?
The Siemens products allow us to go from concept to a physical part in a very short period of time. We use the CAD packages to do our design, our fit checks, our assembly, Teamcenter to do all of the revision control and bill of materials management, and CAM packages to do the programming and ultimately help to manufacture the part.
And I would assume that because all of these tools are integrated, you make a change, it funnels down through the other tools very quickly, or the other.
Yeah, we're actually just getting to that point now to where we completed this first vehicle design, and we're starting to have revisions on our parts and make changes as we've gone through the integration process. And that is one thing that the software just makes really seamless. Any engineering changes just flow through the whole system, and everything's taken care of.
I didn't think about that. You're building product one, right? And changes are small from an iteration perspective at that point.
Yeah, it's a lot of fun.
So Dan, you've worked at race car companies. Now you're working at Impulse Space, and it's a startup venture. Do you have any advice for any budding entrepreneurs who might have a great idea and wanting to start a startup company or maybe work at a startup company?
Yeah, my advice is go out there and do it. You will never learn as much as you will from starting your own venture. Everything that you think you know going in, you're going to learn a whole new thing, a whole new kind of assortment of things as you go to start that. Really, the worst thing that can happen is you'll fail, and even then, you're going to learn a ton from it that will propel your next venture to be successful. So I would say be persistent and definitely pursue it.
That's great advice. Thank you for the insight. So Dan, we're coming to the end of our time together today, but before we go, do you have any other thoughts or comments that you would like to share with our audience? Perhaps something you want them to know about your products, yourself, or Impulse Space that I didn't ask?
No, I think that just about covers it. We've touched on a lot of different topics today, and just wanted to give a big thanks to Siemens for supporting Impulse and other similar startups. That's really important for the aerospace industry and a lot of industries out there that we keep making technological progress. And Siemens products are some of the unsung heroes that kind of run behind the scenes, enabling the creators to do what they do. So thanks again.
Well, thank you for that comment. As the person who's running the startup program and managing it, I appreciate your comments there because we've recognized that it's very important to work with startup companies for many different reasons, but most importantly, so that they don't have to change their tools down the line, right? So they can start with a fully integrated platform right from the start. So Dan, I'd like to thank you for joining the conversation today.
Kevin, thanks for having me. This has really been a pleasure.
It's been a pleasure talking to you, yeah. And I'm so excited about where you're going and how far you've already come. I didn't realize that you had an entire propulsion system. I knew you had a vehicle that you were sending, and the number of missions. I think it's very exciting and much continued success for Impulse and yourself. For our listeners, if you want to know more about Impulse Space or their Space Tug Mirror, you can go to their website at www.impulsespace.com. I'd like to thank everyone for tuning in to today's episode of our Pioneers Siemens Startup Podcast. It's been an absolute pleasure speaking with Dan Olson, the VP of Engineering at Impulse Space. I hope you found his insights on his career, Impulse Space, and Mirror to be fascinating, or as fascinating as I did. We know that startups and small businesses are the lifeblood of innovation, which is why Siemens is proud to offer special packaging and pricing for startup companies on nearly all of areas of the Siemens software portfolio. So if you're looking to take your startup to the next level, please visit the Siemens website, www.siemens.com/software for startups, or reach out to one of our partners to learn more about the exclusive startup packages. And lastly, we'd love to hear more feedback on this episode. Please leave a review on your favorite podcast site or send me an email at kevin.blevins@siemens.com to share your thoughts and ideas on the future episodes. We're always looking for ways to improve and provide you with the most engaging and informative content possible. So thanks again for listening to the Siemens Startup Podcast, and we look forward to bringing you more exciting conversation with the most innovative startup companies around. This is your host, Kevin Blevins. Remember, innovation has no boundaries.